The P5-17 assembly then, we'll try a couple of ways. There'll be a standard and then a kind of a advanced, and I would recommend that you watch both videos and then decide which one you want to utilize. I'm going to go with the millimeter. And since nothing is currently open, I could check my file, but I don't even have the assembly open at this point. I started from a fresh screen, so open in SolidWorks, just the assembly. So I'm going to have to browse, and we'll go to my assignments. And first part that I would want to bring in is the base. Right, and then let's go ahead and open it. Our standard procedure here is just going to be to hit the check mark, which allows the origin of the part to align with the origin of the assembly and become a fixed part. But we also need to, what happens if your part is rotated? What happens if you click out somewhere and the origins are not aligned? All right, so if I right click on the component and float it, now I have something that is free to rotate. Let's get up here to the assembly, and instead of move, we will rotate the component. All right, so some kind of position. So depending on how it was drawn, we're not relying on it being absolutely correct in the part. Our design intent says that we want to think about it, but if it doesn't work out or it doesn't get the desired result, it's okay. We're going to be able to put this in a position. So we have the option to do pretty much what the first insert does. Keep in mind that the assembly and the front plane, these are the planes of the assembly. And then under each component, each part that's inserted, you will have another set of planes that are aligned to the part. So our hierarchy in setting these mate relations is going to be probably a face to a plane to a plane. Right, so one of those, as an example, I can do the front plane to the front plane is coincident. And it rotates and it still looks like it's out of position, but if I go to the top, then I can see that it's going to move left to right and top to bottom, side to side, yeah, left to right again, and not front to back because those planes are aligned. If I go to a face and the top plane of the assembly, so a face of the part to the top plane of the assembly, and those get aligned. And then I could go to a face to the right. All right, but since I align this to the origin of the part to the center, to the mid plane of the part, then I would probably go with the right plane to the right plane. So the choices are, as long as it works out, it doesn't necessarily matter which one. And since this is in our picture, if I have to have it look like the picture in the in our diagram, then I would want to go back and look at something like, let's flip the mate alignment. So each of our mates, probably, most of our mates will have two solutions. And flipping the mate alignment flips, and no, I don't want to see what's affected. It flips it around, holes on that side now, but, well, now the top plane needs to be flipped as well. So it updated, it's telling me, oh, no, turned it back around. So let's try to flip the front plane. Hey, there's a winner. All right, so as I go through the process, I'm going to see the results and kind of keep working at it until I get what I want. If I'd paid attention and done that at the first, then I wouldn't have kind of had to go through all three. But it's a good example. All right, bringing in the next part is going to be, let's see, how do I want to do that? Let's go over to the assembly. We'll run through these again. Insert component. It launched into the open. Let's see if I can move that over, maybe not. So the pin driver should be the 10 millimeter to a 5 millimeter. The pin slider, well, that looks like it's, I still have the naming issues going on. So I want to say, well, let's see if that's open. No. Okay, we'll go back to the drawing found in that piece. All right, so in the naming, kind of followed um, the drawings up until the point where they didn't include them, and so pretty much this is the drive connection. I don't know, something. So that's going to be a misnamed. I would like to say that I am that good that I planned ahead for this, but it's easy to get these confused and naming. And as you're going through the process of developing a project rather than reproducing a project, then you're going to find that the naming conventions are going to vary and need to be flexible enough to account for those variations. So since that's not the slider pin, I'm going to go ahead and open it because it will be a good example. So I'm just going to place it and then select and control select. All right, so selecting the cylindrical face, going to the mating cylindrical face and making it concentric. Don't move the mouse, wait for a good 2 count, and then we can lock the rotation. So once that highlights, now this is going to keep it, it'll move up and down, our 6 degrees of freedom again. I'm now able to move in Z, but not rotate about Z, or in this case, Y. So the top face to the bottom of the pin, select, hold down the control button, rotate over or some combination thereof, and we get those in. Since I lost my move the mouse while the pop-up was there, we'll just come back over to the assembly and go to mate, and that picks up the coincident. Advantage of using the property manager, the mate property manager, is that once I hit OK, it applies it, and if I have other mates, I can just go through and pick. I don't have to hold down the control button. All right, so we'll bring in the drive wheel, and I can insert component. All right, so second method, insert component, existing part in assembly. Watch out for the new part in the new assembly. That's where the virtual components and those types of parts come in. So we're not ready to do that just yet. So I pick my drive wheel, and then we're going to do the same type of thing. Zoom in. Can't emphasize it enough that do not try to pick these faces and edges and geometries zoomed way out. It's going to make it way more difficult. Select Control Select on the cylinder, puts it in position. I do want this one to be able to rotate, at least when we get to a dynamic. And it's kind of hard to rotate around. I can always grab this and move it up a little bit, give myself a little more room. Sometimes that's not going to be as possible, but it, when it's available. Now, if I left click, hold down and drag, I'm going to be able to see that rotate. So our next one's going to be, actually, let's refer to. All right, so the drive pin. See, we did the insert component. Nothing out of there yet. Let's see what the desktop will give us. Let's see. Not going to be easy to find my Google Drives that way, so and we'll go back to our recents list, open recent, and the pin driver, if it is open in the part portion, then under Window, I'm going to be able to switch over to the assembly. Always get Windows and SolidWorks confused. If I do Control-Tab, that is cycling through open documents, and Alt-Tab is cycling through all of the fun windows and all the open windows in Windows. So we can kind of go with the Control-Tab to cycle through those. All right, so since that's open now, I can go into the File Explorer. Notice the variation. The base slider is associated open in the assembly, but not open as a separate part. Same with the driver wheel. Same with the pin slider. But the pin driver, since I opened it, it is an open document, and it shows as an open document, the more solid icon. So we're going to place that close. Just kind of out of habit, I'm picking the cylinders first. So go concentric, need a little more room, separation, and all of those little origins are starting to add up and not be, well, visually starting to be a little annoying. So if I come up to the arrow next to the view, we turn the origins off, it just kind of cleans up the work area a little bit. All right, so now if I rotate, this should be able to rotate in that piece, but it doesn't really affect anything. And this is going to remain underdefined. Let's see, so concentric, coincident. And if I try to grab it and move it, it doesn't. So I'm not sure why there's a minus sign in front of that one, but that's okay. We're not getting any strange results, so there's going to be times where it's not worth chasing those. Let's see if my Windows Explorer is open to my documents, to my Google files. We can drag and drop, so I can bring in the arm, and we'll do the same thing. Now this, I'm not sure how it's going to play out. So concentric wise, it may need to move up and down. So I'm going to hold off on that mate until I get the other components in. So it's going to move kind of strange. I might put a distance in there to align it, but really for the most part, we're okay with this geometry. So let's go ahead and insert one of the pins. So I'll just stay with probably the one I use most, insert component. Oh, and I said watch out for the new part, and that was what I clicked. I want to insert a component, existing part or assembly. Since the pen driver is open, it's currently available. So we're going to grab the pin and place it. So that looks a little big. So obviously I missed something there. So I don't know if that was a default in the hole wizard, but we'll go back and make that correction. So if I right click and tell it to open, since it wasn't open, or if it was open, it will transfer. And we had the 8mm holes and 10mm, and I'm pretty sure that those were 5mm, and I carried that number over. Or no, the 10mm. No, that one was 10. Get it pulled up here. Yep, 5mm. All right, so advantage of the hole wizard is I can go back in, and if we need to add geometry or make changes, we're just going to select to that new size. For some reason, I wanted to switch it to a counterbore. I could make it a counterbore countersink, and it would update without too much trouble. All right, so the window back into the assembly. That looks a little closer to size, and you're going to find and do this error checking as you're going through the process. So this one can be kind of strange. If I want to tell it to go till it seats, then I will probably pick the edge and control select the face, and those can be coincident. It's still a little bit off, so we'll drag it out of the way and then make that concentric. And it could, rotate, not rotate. All right, so since it is now open, I can, not from the design library, I got ahead of myself there. From the file, I can drag in the pin from, oh, I grabbed in the whole assembly, so let's not do that. Control Z. Oh, everything highlighted. Interesting. I have not had it do that before. All right, so apparently I had everything selected and it brought in instances of the entire group. Oh, and there's my virtual component. So interesting little errors. Those are the things that happen that, well, not exactly sure why it did that, but we're going to have to react to it. So going to make sure just the pin is selected this time, and we're going to drag and drop it into the to the mix. All right, so we'll go same thing, bottom of the part, middle scroll wheel mouse, hold down and rotate. And if it had thrown it into the middle of the part, this is where we would use the move, so maybe we'll do that real quick. All right, so maybe it lands in the middle of the part. I know it's there. I can highlight it. I can see its envelope kind of popping up there in orange, but I can't get to it. So if I highlight it, go into the assembly, and move component, I'm going to be able to move it out of that pretty much no matter what. All right, so we can move it up or move it out. And we'll go concentric. That one's good. And I either put it right back in the same one, or I lost the first instance of the pin. Okay, so I deleted one too many. So let's do the control, hold down the control button and pick from the instances, and then we can drag those in, so I don't have to open it back up. And I'm still in rotate. I was seeing the all right, so concentric. And hold down the control button, drag in the next one. Try to find the bottom of the hole. Let's see if we can, we'll do a different style. Let's see, how long was this pin? Should have just measured it. So 16 millimeters. So if I wanted it to be centered, we can go concentric, and then that's a little bit, well, that'll be a good use of the flip dimension. So if I select Control Select and go into the distance, 8 millimeters would be half, but it went the wrong way. So we have this flip dimension that will bring it back up. All right, and then from the work area, if I hold down the control and grab, which is why you want to be careful with some of the selections, then we'll go concentric, and maybe I'll go coincident to the faces. That was a weird little jump, but I'll go coincident to the faces. So if I want to change the depth, we go to the front view and we look at it, hidden lines, and maybe I wanted that seated. I got a couple extra millimeters there. But really in our process, if this is going to be a press, and whatever tolerances we put into the drawing, the reamer, the drill has the drill point, a little bit of a lead. The reamer probably has 1.5 millimeters or 60 thousandths of lead on it that helps the tool start and align to the hole. So we're not really going to get to the bottom, all the way to the bottom. So as long as we have the clearances from the the top and the bottom of the hole. It can be pressed, pins can be pressed in until they seat, and it will work just fine. So this is a good stopping point for the video, and we'll pick up with putting the supports and checking the movement.